thesis of the paper is constructed on top of an a priori defined argument by another paper or another person called, well, I don't know what his first name is, but it's referred to in this paper as the Carter argument. Do you want to summarise what the Carter argument is, Tim?
But the Carter argument is an investigation of the relative probability of life occurring on different timescales. And the argument goes something like this. There are three possibilities for the average timescale over which intelligent life appears on a planet like the Earth. Either intelligent life could appear on such a planet over a timescale much less than the lifetime of the planet and its host star. Or the timescale for life to appear could be similar to the timescale to the lifetime of the planet and its host star, or it could be much greater.
Yeah.
Now, within that window, if we assume that the formation of life and the lifetime of a star are completely independent, they don't share similar processes, so there's supposedly no reason to think that they would be linked in terms of their timescale. So if we assume they're completely independent, then we would assume that there is effectively an equal probability of the timescale for the formation of life occurring within any particular equal time window. But in these three possibilities, the three possibilities describe drastically different lengths of time. So it happening much shorter than the timescale of the lifetime of the planet and its host star is a relatively short window of time. The period where it's a similar length to the lifetime of the star is a longer period of time, and it being much longer than the lifetime of the host star, tens or hundreds of billions of years, is a very, very long stretch of time. So the argument then states that the chances of these two independent processes, the lifetime of a star and the formation of life, occurring over the same timescale is vanishingly small.
Yes.
And therefore life must evolve either at a timescale much shorter than the lifetime of the host star or much longer. And the argument then goes that, well, on Earth, intelligent life didn't form quickly. It didn't form, right after the Hadean period. It took 4 billion years to form. Therefore, the timescale for the formation of life must be, on average, much longer than the lifetime of a sun-like star. And Earth is just very lucky that it just happened that intelligent life appeared before the sun fizzled out and before the Earth was destroyed by its expanding photosphere.
Yeah.